Welcome to section 12.1. We are going to be talking about sequences and series today, and so we're going to start you off with a basic idea of a sequence and then go from there and get more into arithmetic ones. So let's start. Basically what we want you to know is what is a sequence and what is a series. And so we're going to ask you along the way what is the difference, and that's the biggest thing going through, is to know what does a sequence mean and what does a series mean, because if you don't know those words, you're not going to be able to solve the problems for us. So let's keep going. Let's start first with sequence, shall we? As we look at this, a sequence is just an ordered list. More than anything, it's a list of numbers. The items in the numbers are called terms. Okay? And basically, these terms we're going to write out in a list, and that's what the sequence means. Now, the domain are the term numbers, okay? And so when we do it, I'm going to put term numbers because they're asking you basically what's the first term, what's the second term, what's the third term, and so we usually start with 1. The range of our sequence is going to be the numbers that we get out when we plug in a 1, 2, 3, or 4, okay? So here's what we're going to do. We give you this rule in number 1, and we're going to ask you to find the first 5 terms. What that means is I'm going to plug in a 1 to get the first term. So if I plug in a 1 here, 1 minus 1 is 0, and negative 3 to the 0 power is just 1. So we do it again. 2 minus 1 is 1. Negative 3 to the first power is negative 3. Plug in a 3 for the third term. 3 minus 1 is 2. Negative 3 squared is 9. Plug in a 4 for the fourth term. 4 minus 1 is 3. Negative 3 cubed is negative 27. And last but not least, the fifth term, plug in a 5. 5 minus 1 is 4. Negative 3 to the fourth power is a positive 81. And so this is the idea. If you want the terms, you plug that term number in and you get a value out. So let's do the next one. First 5 terms. Plug in a 1 to get the first term. Now I'm going to write it like this. The first term, a sub 1, is 1 plus 4, which makes 5. A sub 2 is 2 plus 4, which is 6. A sub 3 is 3 plus 4, which is 7. A sub 4 is 4 plus 4, which is 8. A sub 5 is 5 plus 4, which is 9. Normally you don't write the term out. You don't say like the first term or the second term, but I want you to see how those numbers kind of correlate. All right, last one, let's try it again. The first term, 1 divided by 1 plus 1. So 1 over 2 is our first term. If I plug in a 2 for my second term, 2 over 2 plus 1 is 2/3. If I plug in the third term, I get 3 over 3 plus 1 makes 4. If I plug in the fourth term, 4 over 4 plus 1 makes 5. And the fifth term, 5 over 5 plus 1 is 6. So far, I'm hoping this is pretty easy for you. Again, you plug in 1, 2, 3, 4, 5, you get a value. Let's keep going. A series, on the other hand, is the summation. We're going to add the terms. Okay, so you add the specific terms that they're asking for you. The way it looks is called a summation notation, or we use the word sigma, and it looks like this. It's like kind of a sideways M kind of idea, and we're going to be working on this. Now, what I want to do, let me change this a second. I want to look at this, and we're going to write out the terms for a while, and then we're going to kind of show you a shortcut. But as I look at this, I am going to go from 1, they always tell you your starting value, to 5. So I want when I is 1, when I is 2, when I is 3, when I is 4, and when I is 5, and I'm going to find all of those terms and then get an answer. Well, this says take 8 times I. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32, 8 times 5 is 40. And I found each term, and now all I have to do is add the terms together. So 8 plus 16 plus 24 plus 32 plus 40 gives me 120. And again, this is a series, which means we're going to add all of our terms up. So we're going to do the same thing, only this time they say start with 3. So we're going to let k equal 3, and then k equal 4, and k equals 5, k equals 6, all the way up until k equals 7. They'll always tell you the starting point and the stopping point. We do the same thing, plug it in for k. So 3 squared minus 1, 3 squared is 9, 9 minus 1 is 8. 4 squared is 16, minus 1 is 15. 5 squared is 25, minus 1 is 24. 6 squared is 36, minus 1 is 35. 7 squared is 49, minus 1 is 48. And I take all of those values and I add them up, and I get 130. Okay? We're going to do the same thing. Let's go one more time. They want us this time to start at 0, though. So if I plug in a 0, 0 cubed is 0. Now I do 1. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27, and I got to stop at 4. So 4 cubed is 64. And I stop there because I stop at 4. And if I add them all up, I get 100. And so we want you to kind of see the idea of what is the basic idea of a sequence. And a sequence just means find the values and list them. A series means add them together. Okay, so let's keep going. We're going to get specifically into a type of sequence now and series, and it's called arithmetic. And when we talk about an arithmetic sequence, I even want to add to this, arithmetic means there's a constant difference between terms. What that means is to get from one term to the next, you're always adding or subtracting the same number. So let's take a look at these. An arithmetic sequence, we want to know, are we adding or subtracting the same number each time? In order to do that, we're going to kind of subtract their terms. So I take the second term minus the first term. So let me do it this way. 1 minus negative 4. That really means 1 plus 4, so I get 5. I want to check the next one. 6 minus 1, do I get 5? Yes. Let's keep going. 11 minus 6, do I get 5? Yes. 16 minus 11, do I get 5? Yes. This then is what we call arithmetic, and we say our difference is 5 each time. And if you look, negative 4 plus 5 gets me 1. 1 plus 5 gets me 6. 6 plus 5 gets me 11. And that's kind of what we're looking for. Okay? In the second one, let's talk about how do you get from 3 to 5? Well, I added 2. How do you get from 5 to 9? Well, I added 4. How do you get from 9 to 13? I added 4. How do you get from 13 to 23? I added 10. Oh my gosh. These are not the same value the whole way through. So this is not arithmetic. There's no constant difference. Okay, we're not adding or subtracting the same number each time. So the idea, I think, is pretty basic. It's then what to do with it as we go through. Now, I realize that I already did this, so let's talk about a rule. A rule is just an equation. Okay? This equation, formula-wise, you'll need to know. Here's what it says. To find the nth term in a sequence, I take the first term plus the difference, and I multiply that by the term minus 1. So it says you add this number for every next term, is really what it's saying. Okay, so in order to write this equation, I must have my first term and my difference. These are must-haves in order to write an equation. All right, so here we go. if you look at this first example, I can look at the first number and say this is my first term. Okay? And then I want to look at the next thing and say, okay, what is my difference? Well, to get from -2 to 3, I add 5. To get from 3 to 8, I add 5. To get from 8 to 13, I add 5. What am I seeing? My difference is 5. Now that I know my first term and my difference, all I'm going to do is put it in that equation. So to find the nth term, I take my first term of -2 plus 5 for every next term. And so what that says is once I have my first term, to get to the next one I add 5. To get to the next one I add 5. To get to the next one I add 5. This means to the next one. Okay, this is my rule. Can I now use my rule to find the 20th term? Well, sure, I'm going to plug 20 in for n. So my 20th term is -2 plus 5 times 20 minus 1. Well, 20 minus 1 is just 19. So 5 times 19 plus -2, you end up getting 93. So my 20th term, a sub 20, my 20th term is 93. Okay? I'm going to skip to number 3 a second. Number 3 says here is the first term and here is the difference. So how do I write my rule? A sub n is the first term, and because my difference is negative, I'm going to say -4 times n minus 1. Here's my rule. How do you find the 20th term? Well, plug a 20 in. 6 minus 4 times 20 minus 1 is 6 minus 4 times 19. You end up getting, where's my answer? -70. Okay, so they give you the rule, and then they go from there. Now, number 2 is the hardest one, which is why I've actually left this one blank. The reason is I don't have the first term, they gave me the 19th term. So what I'm going to do is I'm going to plug this in my rule, and I'm actually going to use my work over here a minute so that you can see it. But what I know is that the 19th term, which is 48, is found by taking the first term plus my difference, which is 3, and because I know that's the 19th term, I'm going to put 19 in for n, so 19 minus 1. Well, this is really 18, and 3 times 18 is 54. So I have 48 equals the first term plus 54, and I subtract 54 on both sides. My first term then is -6. So when I look at my rule then is -6 for my first term plus 3 times n minus 1. Okay, and I just didn't have a ton of room to write, but there's that. Could you then go and find the 100th term? Sure. I'm not worried about once you have the rule plugging in a number. I'm worried more about you getting the rule. And we're going to work on these in class. Again, I'm going to give you a warm-up, and we're going to make sure we can go through these. But this is the general idea. There is another example that I'm going to give you in class, and we're going to go through about how to find a rule given 2 different terms. So I'm going to do that one in class. But take a look. The next one you're looking at is an arithmetic series. And a series just means, again, that we're adding up the terms. Now, if it's arithmetic, and this is the huge part, if you have a common sum or a common difference, then you can use this formula. But that's the biggest thing you have to look at, is you've got to be going up by a certain amount or going down by a certain amount. And in this first example, you can see that we're going up by a certain amount each time, and so that's considered arithmetic. Now, this number up top will tell you how many terms, so that's my n. So here's what I'm going to do. In order to find the sum of 28 terms, I'm going to start with 28 over 2. in order to find my first term, I've got to put a 1 in. So my first term means plug a 1 in. So negative 2 plus 4 times 1, which is negative 2 plus 4 is 2. Okay? To find my 28th term, because I'm adding up 28 things, I plug a 28 in. So negative 2 plus 4 times 28, you end up getting 110. So that goes in my formula as well. So with this arithmetic, you got to know the first term and the last term. Once then I get that, I just plug this in my calculator. What I get for a total for the 28 things is 1,568. Okay, let's try another one. To find the sum of the first 20 terms, let's start here. This is my first term. What's happening along the way? If you notice, I'm subtracting, let me change this, I'm subtracting 3 each time. So my difference is going to be negative 3. Now because I know my first term and my difference, I'm going to start with my general rule. My first term is negative 2, and I'm subtracting 3 for every other term. The reason I have to do this is because if I'm doing the sum of 20 terms, I start with 20 over 2. I know my first term is negative 2. That's my a sub 1. But do I know my 20th term? If you notice, this doesn't tell me what a sub 20 is. And so I had to use this general rule to go back and find a sub 20. So negative 2 minus 3 times 20 minus 1. And the 20th term ends up being negative 59. And so I need that rule in order to be able to find the 20th term. Once I have all the pieces, I throw this in my calculator and I get negative 610. Okay, but again, in order to find it, if you don't know the last term, you have to find the last term using the general rule. All right, last example. John has a first-year salary of $32,500. He gets a salary increase, so he's adding $1,750 per year. That's my D. My first-year salary is my first term. How much does he make in his 15th year means find the 15th term. Well, if I do that, I started with $32,500 and I'm adding $1,750 for the next 14 years is basically what it's saying. What I find is that he made, in his 15th year, he made $57,000. Part B is the series piece of it. How much did he earn in his entire 15 years? Means I take the sum of 15 terms. So 15 over 2, what did he make in his first year? $32,500. What did he make in his 15th year? $57,000. If I stick this in my calculator, I find that in 15 years, he made $671,250. Okay? And we want you to know the difference in questioning between your sequence and your series. Okay? Whether you're supposed to add them or just find a specific term. Now, we're going to be practicing in class on this section because we're missing just a little bit. But I didn't want to make the video super long. So we're going to be practicing a bit, but that's the end of sections 12.1 and 12.2.